everyone. We are going to review solving systems of linear equations using substitution and elimination. So first, we're going to review substitution. So substitution is best to use when the coefficient in front of one of the variables in one of the equations is 1. So if you look here in my second equation, the coefficient in front of x is 1. So this tells me that substitution may be a good method to use. So what I want to do is make sure I isolate that variable. So again, whichever variable has that coefficient of 1. So to do that in this second equation, I'm going to subtract 2y. So I'm left with x equals negative 2y minus 3. And I no longer need this equation anymore, so I'm just going to kind of cross that out. Oh, and this is plus 3. That 3 is positive, so negative 2y plus 3. From here, much like a substitute teacher fills in for the teacher when they are not able to be in class that day, when I substitute, I take this value of x, which is negative 2y plus 3, and I substitute it into the other equation for x. So I now have 4 times, instead of x, I write negative 2y plus 3, and then minus 2y equals 7. The rest of the equation remains the same. So you're going to know you made a good substitution if your equation only has one variable in it. Notice I had 2 different variables in my first equation. I had an x and a y, but now if I look at this equation, I only see y, so I only have one variable. So I made a good substitution. From here, I just go ahead and solve this equation as usual. So distribute that forward to give me negative 8y plus 12 minus 2y equals 7. I can combine my like terms to give me negative 10y plus 12 equals 7, and then subtract 12. So negative 10y equals negative 5, and then divide by negative 10 to give me y equals 1/2. From here, I remember from when I graphed that when I graphed my 2 lines, the solution was the intersection point. So I only have a y value now, so I need to figure out what x is. So I'm going to come back to this equation right here where it tells me what x is going to be to give me x equals negative 2. Instead of y, I get to do another substitution of putting in that 1/2 and then plus 3. So this is going to give me negative 1 plus 3, which is 2. So x equals 2 and y equals 1/2, which we want to make sure we write as the ordered pair 2, 1/2. Okay, so that's the substitution method. Again, you just want to start by making sure you have one of the variables isolated. So again, your best chance of using substitution is when you can find a coefficient in front of one of your variables in one of the equations that is 1. Let's take a look at elimination next. So I actually have the first or the same exact problem in this first example here. You notice 4x minus 2y equals 7 and x plus 2y equals 3. I just want to show you taking a look at it utilizing a different method. So in elimination, we want to look at the coefficients in front of the variables again, but this time we want to find opposites, right? So the opposite of 2 is negative 2. The opposite of negative 5 is 5. So that's what we're looking for, is in front of one of the variables, we want those coefficients in the 2 equations to be opposites. So if you take a look, we do have opposites with the y's, right? In the first equation, I have a negative 2y, and then in the second equation, I have a positive 2y. So when I have opposites, what I can do is add my equations together. So 4x plus 1x gives me 5x, negative 2y plus 2y gets eliminated, hence the name, and 7 plus 3 equals 10. So then I'm going to go ahead and solve for x by dividing by 5, so I get x equals 2. And if you look, we knew x equaled 2 just from when we did the previous method as well. But now we need to figure out what y is. So to figure out what y is, you can go to either equation, either the first one or the second one, it doesn't matter which one, and you're going to plug 2 in for x. The second equation just looks smaller to me, so I'm going to use that one, but it actually doesn't matter which one you use. So again, this 2 here is just the 2 from x. So now I have 2y equals 1 when I subtract that 2 over, and y equals 1/2. And as you can see, we do get the same answer that we did previously, which is 2 1/2, just a different method of getting there. So you can actually choose your favorite method of which one works better for you. I'm never going to ask you specifically to use one method or another. Okay, so if we take a look at this next example here, I don't have opposites right off the bat like I did in this one where I had a negative 2y and a positive 2y. However, I noticed that if I multiply my second equation by 3, that would give me opposites. So now the second equation would become 6x minus 3y equals 21. You want to make sure that you distribute that 3 to all the pieces in the equation because I've created an equivalent equation. That's just a factor of 3. Okay, and then this first equation is going to stay as is. So now I've got the opposites that I want. So I'm going to go ahead and add my equations together. 4x plus 6x gives me 10x. 3y plus negative 3y gets eliminated. And 4 plus 21 gives me 25. And then from here, again, I'm going to divide by 10. So I get x equals 5/2. And it's better just to leave it as a fraction, as an improper fraction, than to write it as a decimal. Okay, so again, we still need to know what y is. You can come to any equation, and I'm just going to come to this one here, just because it looks the most simple in terms of the numbers, but really you can use any equation you like there. So now 2 times 5/2 gives me 5 minus y equals 7. So negative y equals 2 and y equals -2. So my solution here is 5/2 -2. And write x and then y, because remember your solution is the point where the two lines would intersect. Let's take a look at just a couple more here. So this next one, if I'm looking for opposites, if I look at the coefficients of x, I have a 3 and a 5. And if I look at the coefficients of y's, I have a 7 and a 2. So it's not clear right off the bat how I'm going to be able to get opposites here, like it was in the previous example where I could go ahead and just multiply by 3 to give me those opposites. Let's eliminate x this time for fun because we just haven't done that yet. So if I want to eliminate x, and again, you could choose to eliminate y if you like that better, but if I want to eliminate x, that means that I want there to be opposites in front of x. So in order to do that, I'm going to go ahead and multiply the first equation by 5 and the second equation by -3. Because notice when I do that, the coefficient in front of x would be 15, and the coefficient in front of x in my second equation would be -15. So I'm going to get those opposites. So now my new equation here is 15x plus 35y equals 75. And then here, my second equation becomes negative 15x minus 6y equals 12. Now I'm ready to add those babies together. 15x plus negative 15x gets eliminated. 35y plus negative 6y gives me 29y. And 75 plus 12 gives me 87. And when I divide by 29, I get y equals 3. So now from here, again, I need to figure out what x is. So come back to one of your equations. I'm going to go with, and this bottom one is just always looking more simple to me, but really you can choose any equation you like. So I have 5x plus 2 times 3 equals negative 4, and that 3 came from what I just found y to be. So now I have 5x plus 6 equals negative 4, 5x equals negative 10 when I subtract 6, and x equals negative 2. Again, make sure that you write that as an ordered pair, so it's negative 2. Okay. Last one. So let's take a look here. Well, actually, before we get to the last one, so the point I want to make is that sometimes you don't, with using elimination, you don't have to multiply either equation. Sometimes you may only multiply one equation, or sometimes you might have to multiply both equations. So again, it's just depending on how you're going to get those opposites. Okay, so if we look at this next one now, I can see that I actually only need to multiply the top equation by 2 to give me opposites. So that gives me negative 6x plus 10y equals 14. And then this equation is staying the same. Now, when I was first thinking about doing this problem, I was only looking to eliminate x. Well, look what happens. Negative 6x plus 6x, oh, gets eliminated. 10y plus negative 10y, oh, it's eliminated. So I have nothing left on the left-hand side. And 14 plus negative 14, oh, gets eliminated also. So I have nothing left on the right-hand side. So 0 equals 0, that is a true statement. So this means that there are infinitely many solutions, because really what this means is this is that example that we did in our graphing day, that these are actually the same line. Okay, so if I were to graph them, it would be the same line. So what points do they have in common? All of them. So to write this, my infinitely many solutions, we have a fun little set notation here where we make this fun little curly bracket, and you guys could practice making that. And it says any xy, so that's just any ordered pair, such that, and then we say we pick one of the equations and then put a curly bracket. Okay, so again, I'm going to repeat that because this is how we're going to want to write our answer, is we use those curly brackets, and then you say xy, so this is referring to any point such that, this vertical line here means such that it lies on this equation here. And again, you can choose either one. You're just saying that it's any point that satisfies this equation. So we're going to continue to work with substitution and elimination in class tomorrow, but just wanted to again remind you of these methods. Thanks so much.